My responsibility, I guess, is to introduce Dr. Nelson. Dr. Nelson is professor and chair of the Department of Agriculture, Agribusiness, and Environmental Sciences at Texas A&M Kingsville. He was appointed to the faculty in 2001. He oversees the horticulture option of the Plant and Science degree plan and holds a 25% appointment based out of the Texas A&M Kingsville Citrus Center in Weslaco. His research program assists growers in finding alternative irrigation methods that will enable growers to produce citrus using water conservation practices. Dr. Nelson believes that research projects that incorporate multiple disciplines will be better suited to address these challenges. Dr. Nelson was born in Southern California and raised in Provo, Utah. He's a third-generation soil scientist. His father was professor of soil science at Brigham Young University, and grandfather worked for NRCS. He received a PhD in soil science from the University of California, Riverside in 1998 after completion of a MS and BS degrees at BYU in agronomy and horticulture sciences. I've had the privilege of working with Shad on the irrigation project in the valley, where we've done some work together, particularly on citrus. And I'm going to turn it over to him.
Thank you, Mac Young. I appreciate it. I appreciate you all coming this morning or this afternoon. Wise man once told me that if you don't have anything intelligent to say, at least look smart. So hopefully I dressed appropriately. It's definitely not how I show up to work. We're going to get into crop and management water management strategies that we do for the citrus production. But I'd like to acknowledge some of my collaborators, people that I work with. I work with an entomologist, Dr. Mamadou Setamu, and we collaborate with our graduate students that are typically housed at the Texas A&M Kingsville Citrus Center. So some of the work from Diego Garza, Juan Melgoza, and Marisol Esparza, who recently graduated with their master's degrees, I'll present some of their work. And I've also been working for quite a number of years, at least 8, with Dr. Juan Enciso and Mr. Mac Young, probably 6 or more. How many years? It's been 7 years. So agricultural engineer, Juan Enciso, and Mr. Mac Young is extension economists. Just to give you a little bit of background about the lower Rio Grande Valley, some of the demands, the challenges, the opportunities that exist in the citrus industry. You may be aware that the lower Rio Grande Valley in South Texas is the primary region for citrus production in Texas, mainly because of where it's located. South Texas is known for producing high-quality, deep red grapefruit varieties. 70% of the citrus down in the valley is Rio Red grapefruit. And which becomes kind of a interesting situation for us because most of that citrus production is performed by flood irrigation. So we have an opportunity for some crop and water management relationships down there. Most of that water comes off of a single source, off the Rio Grande River, and it's a good quality water, good enough to raise vegetable production, field crops, as well as citrus production. But because the Rio Grande River really supplies water to not only agriculture and horticulture production down there, it really is the water supply for population itself. And because of population growth, and one of the fastest growing regions in the state of Texas is down along the Rio Grande River, we have some challenges, especially during times of drought. Despite the fact that this region's prone to periodic droughts, even now, deciding not to irrigate citrus is just not an option because it's a perennial crop. It needs water. If we want to keep those trees alive, we have to irrigate. Over 85% of the citrus in Texas is grown under flood irrigation, and if we get into water restrictions, we still try to have our trees surviving, we need to move towards some more water conserving practices that are economical and something that we can put into practice today. Some of the things you may not be aware of, South Texas, most of our soils down in that region are pretty heavy. It means they have a high clay content, very low organic matter content. The soils are highly calcareous. There's a lot of calcium inside those soils, but most of the citrus is produced on a sour orange rootstock. And that's a very good rootstock for our area. It tolerates the soils that we have. They tend to be prone to some plant pathogen problems. Phytophthora is one of those issues. But it's been a good rootstock, and people are pretty content with it and rely upon it. South Texas is the third largest citrus producing state in the U.S. Having said that, our citrus production is actually fairly small. We only have about 11,000 hectares or 27,000 acres of citrus under production. Relative to Florida, relative to California, we're a small player in the citrus industry. But we do have a niche. We have the deep red varieties of grapefruit that are very sweet, and really there's not anyone else in the world that really produces the quality of grapefruit that we can produce in South Texas. And a lot of that has to do with where we are, the soil types, and what we've been able to find off of our previous grapefruit varieties. But we are prone to problems. The biggest problem is citrus greening disease. Long bean, or HLB as it's known, has devastated the Florida citrus industry. And unfortunately, last year in January 2012, I was there at the Citrus Center when we discovered the first positive for HLB. And now we have a quarantine area in the San Juan region down in the lower Rio Grande Valley. But we're not in the situation that Florida's in. And so there is a lot of hope and optimism for us to be able to control this with things that we've learned from Florida. But still, that's a problem that we'll be dealing with from now until maybe forever. We hope we can get this under control. But I'm going to present a few things that get into some of the crop management strategies that we have to combat HLB, but also what can we do to be able to assist growers at solving the water quantity problems that we have. First off, let me talk a little bit about the water quantity side. In the lower Rio Grande Valley, water consumption along the Rio Grande River is distributed by as many as 27 different irrigation districts. And each irrigation district allocates their water typically through a canal system, and it gets out to the different farms, and they deliver that water at a different price. If you've ever been down along the Rio Grande River, you'll notice that there are several pump houses that are located next to the Rio Grande River. And it doesn't take a lot of energy to lift that water from the Rio Grande River level up into those canals. And so some growers live right along the river. They may have their own source to get that water out of the river. Others have the pump houses that get it into the canals. Regardless, water is pretty cheap in South Texas relative to other locations where they may be taking water from a well, where it takes extensive energy to get that water up to the surface level. Water for the lower Rio Grande area is relatively inexpensive. And for that reason, there really isn't an incentive for growers to change from what they've been doing for many, many years. which is primarily flood irrigation. So the Texas Water Development Board, after we went through a drought period through the 2009, 2010, I guess it would have been 1999 and year 2000, before I was hired in 2001, they allocated $10 million and set it aside for water conservation work. And a third of that money came down to the Harlingen Irrigation District, which was split between Harlingen Irrigation District and Texas A&M University Citrus Center, and also to the AgriLife Extension Centers in Weslaco and Corpus Christi, to evaluate on-farm water use in the Rio Grande Valley. The project was called the ADI project at that time. It's now been renamed. I'll talk about that a little later. But it stands for the Agricultural Water Conservation Demonstration Initiative. And the purpose was to evaluate and promote more water-conserving irrigation methods at the on-farm level. And basically, we were supposed to go to the growers' fields and work with the growers and see what they were currently doing as far as irrigation practices and what was currently working. Excuse me, I'm fighting a cold. Directives of the ADI program, we really evaluated 4 main irrigation systems. One, traditional flood irrigation practices, which is basically large pan flood irrigation, irrigating a large section of the field at the same time. Border flood irrigation, which I'll explain a little later. Drip irrigation methods, and also microjet spray sprinkler irrigation. Traditional flood, as you kind of think about it, it's kind of like irrigating a whole section of the field. Typically, they'll raise berms about every 3rd or 4th or 5th row of trees and irrigate that whole section at one time. And typically, it takes about a 6-inch irrigation event, all right, or a half an acre foot just to irrigate that amount of land area for each irrigation event. Some people will use a poly pipe to distribute that. Most of them just open the valve, all right? Border flood is raising a berm, a wide berm, in the middle of every tree row, and then trying to channel water as fast as you can underneath the canopy of the citrus tree. That's a water conserving practice because you're moving water down the row faster in a lower period of time, but you're also not irrigating the entire surface area of the farm. So border flood irrigation practice also can use poly pipe, but one of the nice things about poly pipe or often the meter, you can meter the amount of water that you use. We've done some studies to determine how much water is being used by traditional flood versus border flood. I'll show some of that work. Microjet spray irrigation. Microjet sprinklers, they put out a fine spray pattern underneath the canopy of the tree, and it can concentrate that water basically right underneath the canopy of the tree, and that's what's nice about that. So here's a little demonstration of what they do. Typically they're placed in between the middle of the trees. You have a fine spray that goes out underneath the canopy of the tree, and then that water can move and distribute itself down into the soil profile. And you can irrigate really well where most of the feeder roots of the trees are. And most of the feeder roots for citrus are within the top 18 to 24 inches. All right? So in flood irrigation, typically flood irrigation, when you put on a 6-inch irrigation event, that water will typically distribute itself 3 feet, even 4 or 5 feet down in the soil profile. A lot of that ends up moving in an area where the citrus tree doesn't necessarily use it. In drip irrigation, most growers with drip irrigation will use a single drip line. There's a challenge with that, especially when you're dealing with mature trees and drought scenarios. Single drip line, they typically put that drip line right next to the trunk of the tree, and they hope that water movement will get all the way out to the drip line of the tree, or where the water cascades off of the leaves of the tree. What we found as we put soil moisture sensors out to the drip line of the tree is water doesn't really move in our heavy soils that far. In fact, we have out at each side of the drip line tree places where we are under irrigating or we don't irrigate at all in those areas. So if you go a full year without a precipitation event or a rain event, you really stress trees under single drip line. Most of the growers will try to keep their trees alive by opening the valve and flood irrigating every 4 or 6 months if they have a single drip line, if they're going through a drought scenario. But if you have land that's uneven, and one of the reasons why you might invest all the money for a drip line is because you have uneven land, all right, it's not laser leveled, well, you can't really flood irrigate that situation, right? So how do you remediate that? Well, we counsel the growers to go to a dual line drip system, which costs more money. It costs about $1,500 per acre just to establish a single drip line, right? So you can get into $2,500 an acre for a dual line drip. But the nice thing about a dual line drip system is you can put those drip lines about 1.5 feet away from the center of the trunk of the tree, and then water will distribute itself laterally to where almost all of the feeder roots are located, even out to the drip line of the tree. So during these drought periods, a dual line system is really becoming one of the things that the growers need to invest in. What I'd like to focus in is how can we help the growers now that are really confined to a system that was built around flood irrigation. Water is inexpensive, all right, it's relatively cheap. As long as it remains relatively inexpensive, there's really not an incentive to change. So how do we get the growers to move into a water conserving method, knowing that they're not necessarily going to want to move to drip irrigation or microjet irrigation because it costs $1,500 per acre just to establish that kind of system, all right? So Mac Young and I have looked into traditional flood versus narrow border flood and some of the work on the amount of water that's being used, but also what kind of yields and the quality of fruit that comes off of that. And we have a publication here we'd like you to pick up if you'd like to take care of that and look at it later after this presentation. But let me show you kind of how water moves in a citrus grove. We did a study to evaluate how water moves inside a large pan flood irrigated site compared to a border flood irrigated site. And this is how water moves. And pay attention to the time on this. If you have a single valve that's about 10 to 12 inches and you open it up, all right, allow water to move down the field. Water moves down the field not like in a bathtub. Water actually moves down the field between the rows where the trees are not located. And water fills in that area and it won't move into the trees until, all right, here we've passed almost 2.5 hours to irrigate these 3 rows of trees. That's how much water we're applying. But why does water move that way? The truth is, the field isn't flat, all right? We have equipment that goes between the grows. We typically spray to control pests at least 8 to 10 times every year, all right? So we're lowering the elevation of the trees. Every time we go in to harvest those trees, we're also compacting the soil between the rows. If you're flood irrigating, you have weeds that grow in that place as well. So you'll go in and you'll cultivate a little bit to mow those weeds down. Because that elevation is a little lower, water fills up that low elevation first, and it's not going to go up higher until the lower areas are filled up. That kind of makes sense. Water moves to the lower place. But what happens overall? Well, if we really want to establish a 3 or 4 or even a 6-inch depth of water, we have to wait until that water builds up to that height. All right? What happens to all the nutrients that we've applied underneath the tree, or some of the chemicals that we've been applying? Where are they moving? They're moving beyond where the effective rooting zone is, and now they're moving into our shallow water tables, because the water table is actually fairly close to the surface down in the lower Rio Grande Valley. So now we're leading into environmental concerns besides just a water conservation concern. Let me show you what happened in our research study for the narrow border flood, where we have berms raised between each row. We're trying to channel water faster down the road. Water actually behaved differently. All right? Water was moving down the row, and if you'll pay attention to the time, we can get to the end of the rows within an hour. All right? Just kind of makes sense that we're going to save water there. And then we wait for that water to raise to the appropriate depth. Typically, we apply a 4-inch irrigation event for border flood compared to a 6-inch irrigation event for traditional flood. Again, this is all we're doing. All right? We can target better under border flood irrigation the root zone and where the roots really are. And more importantly, we're not going to distribute that fertilizer or pesticide beyond where it's going to be effective for the trees. So if you look at annual water savings, this is off of about 5 years of data. This is the average over 5 years data, looking at the growers that we've had participating in the ADI program. Compared to traditional flood, border flood, microjet, and drip all saved a significant amount of water compared to traditional flood irrigation. About 35%, all right? If you think about the entire citrus industry, which has 27,000 acres of citrus in the lower Rio Grande Valley, if we just switch those traditional flood irrigators to border flood, we could save about 17,000 acre-feet of water every year. And that becomes critical. I mean, if you think about 27,000 acres and we can have a 4-inch irrigation event for border flood, we could have an extra 2 to 3 irrigation events during a critical year if we save that water. But what does it do for yield? Really important thing, growers don't really care about saving water because it's relatively inexpensive. What they care about is yield. And what's interesting about this slide, regardless of the grower's practice for irrigation, the yield quantities were about the same, or on average, okay? So where does the incentive to the grower come in to change an irrigation practice if there's no change in yield? Well, this is where Mac Young and I were looking at not only yield, but the quality of the fruit that comes to from the field. Growers are paid not just the total quantity or mass of the fruit, but how it's graded. The citrus market in Texas is really made for the fresh market. All right? The grower makes money if it goes to the fresh market and not the juice market. In fact, if they have fruit go to the juice market, it's almost not worth harvesting. They break even just by doing that. They don't make money in the juice market. So the higher percentage that goes to the fancy class, they get the highest dollar return for, and then the choice class is also a higher dollar amount, not as high as fancy. So if you look at just the border flood compared to traditional flood, microjet, and drip, you have 47.3% in the fancy class, which is higher than the others, 23% higher in the choice, but the lowest percentage going to the juice class. How does that end up as an economic savings? If you just look at traditional flood growers compared to border flood, over a 10-year cash flow they're making $19,000 per acre in border flood compared to $9,000 in the traditional flood. Here's the economic incentive to change the system. Just a simple management practice of raising borders between rows, we can come out with better fruit. Why would that happen? It kind of makes sense, though, if you think about it. What was happening to the fertilizer? What was happening to the chemicals that were trying to control pests? Where were they moving under traditional flood? We're moving them out of the effective root zone where most of the feeder roots are, taking those chemicals, those fertilizers, additional dollars that we're putting into the fruit. And it really pays off to the grower if you can change the method. So some conclusions just from the ADI project. Growers that switch their irrigation practice from traditional flood to border flood, they can save water, almost equivalent to a drip irrigator or a microjet spray irrigator. Alternative flood irrigation practices, we've seen growers save 50% water. In a research study, we showed 35% water savings with border flood compared to traditional flood. And citrus producers with established mature groves that want to conserve water will have better fruit quality, higher average yields, and greater net farm income by changing to an alternative flood irrigation method. That's great news for the valley because the grower doesn't have to do a lot to change. He just has to change one management practice. Now the Texas AW project is the name which the ADI project has been renamed. It's actually the Texas Project for Ag Water Efficiency. It was renamed within the last year. So not too many people are familiar with the Texas Project of Ag Water Efficiency, but that's really what we're targeting. We're trying to find more efficient ways to use water, but also use water in a way that the growers will have the best bang for their buck and have an incentive to make that change. You can find more information about that at the Harlingen Irrigation District website. It's at www.hidcc1.org. Now let me talk a little bit about some of the work I've been working on with my graduate students, looking at some micro and macronutrient impacts at improving citrus health to combat citrus pests and HLB. ACP stands for the Asian citrus psyllid, and many people are familiar with this insect. It's actually all over the state of Texas. And in the southern region, Asian citrus psyllid is almost everywhere. But this is really the causal agent for disrupting good citrus production in Florida right now. All right? It carries a bacterial disease called HLB, or Wong Lung Bean disease. And some of the symptoms that come from this, you'll see a blotchy mottling of the leaves, some yellowing inside there. Here's a few pictures of what that mottling looks like. You'll have some fruit that won't ripen. You'll stay green. You'll have lopsided fruit in the end. All right, so you'll have small green fruit. You'll be asymmetrical. You'll have aborted seeds. And you'll have a bitter taste to the fruit. Now, the Asian citrus psyllid, that bacteria can be inside the egg itself, inside the nymph, inside the adult itself. You can recognize the adult because it sits at a 45-degree angle off of the leaf when it's feeding. Has a piercing mouth part that injects the bacteria into the phloem of the tree. Well, I had been looking at compost as an alternative to save water, kind of preserve water under the citrus trees. And one of the compost sources that we looked in at was sugarcane waste compost. We found some interesting, surprising results with this compost. This compost As we looked at the Asian citrusillid populations of the trees where that compost was applied, we had lower Asian citrusillid numbers in adults, eggs, and nymphs as the calcium concentration in the tree increased. That calcium source was coming from the compost. That sugar mill waste compost was high in calcium. All right? And that calcium was being taken up by the tree. And with more calcium inside the tree, we actually had a lower pest pressure on those trees. And that was kind of an interesting thing. So we looked into that a little further. Well, out in Florida, there's a grower by the name of Maury Boyd, and he's been using his own cocktail mixture of macro and micronutrients to boost the nutritional value of his tree. All right? His trees out there have 99.99% of them with confirmed HLB inside them. All right? He has the disease. This is his farm on the right side. And on the other side of the road, you have another farm. And the truth of it is, both of these farms have HLB all throughout. One side of the farm is actually ripping out their trees and replanting, where his side of the farm on the right side, his trees look great. They have the disease, but he's still able to produce fruit because he's using this nutritional plan in addition to dealing with the disease. He hasn't been ripping out his trees. So we looked in at what he's using in the Maury Boyd cocktail. One thing that we noticed that wasn't listed there is the macronutrient calcium. And so we wanted to say, okay, well, we've already seen this calcium effect with that compost. Let's see if we can focus in and see if there's something there. So we looked at different sources of calcium, both foliar applied and soil applied calcium sources. The foliar applied sources that we used were calcium metallosate and calcium thiosulfate, and the soil applied sources were calcium nitrate and gypsum, or calcium sulfate. Come to find out that Maury Boyd also applies calcium nitrate. All right? What we found as results, you have the soil applied sources on the left side and foliar applied sources on the right side compared to the control. And you'll notice that the adult Asian citrusillid or Diaphormini citri adults, ACP, okay, the least square means are significantly lower on all calcium treatments compared to the control, except for the gypsum, which was intermediate. Well, one of our graduate students wanted to look at different foliar sources as micro and macronutrients. So we looked at a series of different treatments, a control where we didn't apply the nutrients. We had a potassium treatment, a calcium alone treatment, crop up, which had magnesium and some micronutrients in there, potassium plus crop up, calcium plus crop up, and then calcium and potassium and crop up. So we applied these to our trees over 2 years. And here's the results. In the center, you have the control treatment, but you'll notice that on the right-hand side, all treatments that did not have calcium, all right, had higher levels of Asian citrusillid on the flesh of the tree compared to the treatments that had calcium. So if you looked at the adults, we take counts for the adult psyllids that we saw, the eggs that we saw, and the nymphs. And in the adults and the eggs, wherever we had calcium, we had significantly lower numbers as compared to non-calcium treated trees. If you look at the percent reduction, how much of a reduction in the Asian citrusillid population did we actually have? It ranged from about 16% to as much as 25%, which isn't 100% control, but we don't expect 100% control. But it's very, very interesting that here in soils that are high in calcium, we can add soil-applied calcium and we can apply a foliar calcium source and decrease Asian citrus psyllid populations. Think of what would happen applying that into Florida, where their soils are sandy, not calcareous like ours. How much more effective will that calcium nitrate or foliar calcium treatments be for their control programs? All right? If you look at impact on yield, all right, so the end of the year yield, if you take the calcium treatments, lump those together compared to the non-calcium treatments, we had higher yields of the calcium treated trees. So some of the things I'd like to just sum up here is results showed that adding calcium significantly reduced Asian citrus psyllid populations or infestations on grapefruit trees. The reduction in the percentage of flush on the shoots varied from 16 to 25%. Nutrient applications then can be a support to lower Asian citrus psyllid infestations, and this is good news. Good news if you're an organic grower, because what do you do to control this insect pest? What if you're a homeowner, all right, and you don't want to apply pesticides? You're still going to have the problem with this disease, because we have this Asian citrus psyllid everywhere. Results have shown that an addition of calcium may improve grapefruit yield. These findings are impressive, especially the fact that our soils are already high in calcium, and the potential benefits may be even greater for citrus-producing regions where soils have low calcium content. And those studies need to be looked into. Here's just a last shot of many of the people from the Citrus Center that help graduate students, the visiting scientists from Morocco, and Dr. Setamou is down, and he really is one of the spearhead leaders for the Citrus Center in the research side. And one great thing about Dr. Setamou is he loves to collaborate with anybody, and he knows his work well. That the results that come out from his lab are very meaningful and important to the citrus industry, and especially for our region. That being said, I thank you very much for your time. If you have any questions, I'll take some questions right now. Yes?
I have a question. You said they have found that vectoring disease in the eggs and in the hen, as well as the chickens?
That if they're feeding on the flush and that flush has that bacterial disease, they can get it. And as far as I know, it's reproduced that bacteria through the population. Of course, I'm not an entomologist, so I'm just saying that.
Because I wondered how come more of the population is psyllids than don't have that, because if the transmitted the brood would have more.
Yeah. And I may be stepping out of my bounds actually saying that.
Oh, I know this is very interesting.
Yeah, the difference between the rows on the citrus production. Does that have an effect on the different ways we manage pests and the harvesting of those? That you have to pound that every time you want to water it.
Very good question. The question is, with raising those borders between the citrus rows, does that alter management practices for the grower? Does he have to take those rows down and then irrigate and raise them up every irrigation event? It depends on the grower. One grower keeps them up all year round. So when it comes time to harvest, he'll take those beds and look and make it flat. But the rest of the year, when he's doing his spraying, he can go right over, and the wheels go on the sides of that bed, and he doesn't have a problem going down the road. Another grower just prefers to raise them right before every irrigation event. And most growers have got in the habit of every 3 or 4 weeks ordering the water and irrigating. So they know when their water is going to come, they raise the bed, and then they mash them down. But obviously, that's a cost in fuel every time you do that. And so we found that the best producer that we have doing border flood only raises them once a year. Right? He's very effective, and he can get better return just by doing that because he's lowering the fuel cost.
Another question is, how do you use the information of other farmers to get the plant cost? There's a financial statement.
The question is, how do we disseminate this information so the other farmers can find out about border flood irrigation methods? We have had two irrigation expos down in the lower Rio Grande Valley, where we've invited all of the growers to come listen to them through extension publications that come out from Mac Young, Juan and CISO, presentations such as this, and we have periodic workshops where they'll invite Juan and CISO, Mac Young, and myself to discuss what we're finding and how that can promote and benefit the citrus industry. But more importantly, because we incorporated growers themselves from the beginning on the data collection, their word of mouth to the other growers, because they go to the coffee shops in the morning and they discuss with the other growers. The growers really see that as something that they can rely on. You know, not just a researcher saying this is good. It's coming from the grower himself, and they're supporting what we're sharing. Okay, the question is how close are the water tables to the surface, or how high are the water tables? In some regions, depending on where you're at, they can be as close as 5 to 6 feet from the soil surface. All right, most of those are probably around 8 to 9, and then depending on if you're further inland, they can be 12 to 15. But there is a big reason why we're limited to the lower Rio Grande, in the lower Rio Grande area of using water off the Rio Grande. We have too much salt intrusion from the Gulf of Mexico. And so water quality, taking it from the ground for the most part, is poor in comparison to the surface water.
On the average, they put out about 6 inches of water flood versus 4 inches
For border.
water. And you explained well, possibly you're not losing as much of the nutrients. I would also oppose this to, even though we're trees and they're not in the plants, 4 inches versus 6 inches, quite a bit less water in the root system. Water low, even there'd be some action in the photosynthesis. All the point does it. The root's not being exposed. That may be a factor back to the quality.
Right. Yeah, you can stress trees several different ways, and flood irrigation management is a stress system anyway, because you flood irrigate, you have near saturation conditions in the soil for a period of time until it gets down to field capacity. Then the tree has to take some time to take up the water until it gets into its optimum uptake, and then typically that water is being used within 2 weeks. Then you get into almost a stress scenario before you get back into irrigating it 2 weeks later. And so it's always going through this stress of high water, low water.
You had a graph, and you was talking about calcium, and you showed adults and nuts and eggs. How come calcium is more effective? This may be an entomology question. But why would you think it was more effective on the adults and the eggs than the nuts?
That's a good question. The question is why on the one graph did nymphs not have a significant difference for the calcium treatment? Nymphs are affected by predators a lot more. They go through 5 stages in the nymph stage before it gets to the adult. The adult can fly, it can move, the eggs stay there, and they're not fed on like nymphs. So there are a lot of things that are out in the field, and it's common in entomology studies to see a lower effect for those nymphal stages just because they're affected by environment for a longer period of time or predators. And so that's one of the reasons that could possibly explain that. Very good. Thank you for your time. Appreciate it.